I've spent a bit of time testing this brand new mini PC, the Seer 10 from Beelink, against last year's model, the Seer 9, and the Seer 8 before that. They all look kind of alike, but inside they're different because the Seer 10 has AMD's new Gorgon Point chip versus the previous Strix Point. And after doing my developer and LLM AI tests, I came out with something I didn't expect. All right, so this is the Beelink Seer 10 Max. They added Max to it. It's got the Ryzen AI 9 HX 470, codename Gorgon Point. But the real shopping question here is 3 machines, not 1. If you take a look at the Beelink site, last year's Seer 9 still available, still hot, and still on sale. Usually a couple of $100 cheaper. In fact, I've been using mine now for a while, for more than a year, as a media server. And as a side note, this is what it looks like if you just have it on a rack for over a year. It's got a little bit of dust, but it's not too bad. Really solid machine. The other option is the M4 Pro Mac Mini, which I also have set up here. I'm including that because the M4, the base M4, caps out at 24 gigs, which is really not that great for a lot of the workflows I'm going to show you. And also, since we're comparing it to the Seer 10, which is at 32 and 64 gig configurations, and we should go to the M4 Pro. For the M4 Pro though, Apple charges some serious money for that. This is the basic M4 Pro, not even the 20 core GPU, and it's 48 gigs, not the 64 gig version. Do they even have the 64? They got rid of that? Let's go to 1 terabyte. 10 gigs Ethernet? Suddenly you're at $2,000 and you're only at 48 gigabytes of RAM. So the Beelink side still makes sense. You're only going up by a couple of $100 and you're way under that. This does come with 1 terabyte of storage. So the question isn't, is Seer 10 a good upgrade? It's, should I get a Seer 10, Seer 9, or save up for the M4 Pro or the upcoming M5 Pro whenever that comes. But this is a performance video, so we're gonna get into that. So these days I'm always flipping between models. GPT for research, Claude for coding, Nano Banana for image generation, VO, Kling, and Runway for video, 6 tabs, 6 bills, and counting. Enter Chat LLM Teams. One dashboard houses every top LLM, and Route LLM picks the right one. GPT Mini for ultra-fast answers, Claude Sonnet for coding, Gemini Pro for massive context. They recently added Gemini 3 and GPT 5.1 the moment they dropped. Create professional presentations with graphs, charts, and deep research detailed content. Need human-sounding copy? Humanize rewrites text to defeat AI detectors. Need visuals? Pick Frontier or open source models. Nano Banana, Midjourney, Flux for images, Magnific for upscaling, plus VO, WAN, and Sora for video, all built in. You also get Abacus AI Deep Agent to pretty much do anything. Build full-stack apps, websites, reports with just text prompts, and deploy them on the spot. They have Abacus AI Desktop, which is the brand new coding editor and assistant that lets you vibe code and build production-ready apps. And the kicker? It's just $10 a month, less than 1 premium model. Head over to chatllm.abacus.ai or click the link below to level up with Chat LLM Teams. By the way, if you don't know what a Gorgon is, this is a Gorgon. I don't know why AMD has to go with scary things for their chip names. This one will turn you into rock if you make eye contact, so don't do it. Some quick specs on this chip. We've got 12 cores and 24 threads, Zen 5 architecture plus Zen 5C, 8 of those, and it boosts up to 5.2 gigahertz. Check it out. Shared memory, half of the memory can be shared, 29 gigabytes in my case. So AMD's marketing material obviously will include the NPU. The use cases are limited, but I'll show you how we can use that later on in the video. And the iGPU is here too. This happens to be the Radeon 890M. If that sounds familiar, you're right. It's the same one that was in the Seer 9. More on that later. The memory here, I have 64 gigabytes on my machine, but it does come with 32, and this is DDR5 5600. User configurable and user upgradable, which is different than the Seer 9 was. You can also upgrade the storage up to 8 terabytes if you can find it and afford it. A few other life improvements like USB 4, HDMI 2.1, DisplayPort 1.4, and 4K at 240 Hertz triple monitor support, and 10 gigabit network Ethernet. So that's pretty cool considering the Seer 9 only had 2.5. Now, if you're so inclined, There's also nice looking orange one. Is it orange or red? I don't know, but it's got OpenClaw pre-installed on it, and they're charging $100 more for it. But look at this option right here, 96 gigabytes with 2 terabyte SSD for $2,300. This 96 gigabytes for that much is actually not bad right now. If I spec the 2 terabyte version of a Mac Mini, we're at $2,500 and we're half the RAM. But it's kind of funny that they're charging $100 more for the OpenClaw version of this. And it's definitely not as bad as that guy on Craigslist who was charging $1,500 for a base Mac Mini with OpenClaw pre-installed on it. All right, let's start light. Speedometer 3 is a JavaScript benchmark. It simulates real web application interactions, the kind of thing you feel every time you open a sluggish site, single-threaded, and everyone's got a frame of reference for this one. The Ser 9 hit 31.5 in the 7-way comparison video that I did not too long ago. That one had a bunch of other mini PCs included. Last year, the M4 Pro Mac Mini got 45.2 in that. The base M4 beat the M4 Pro, got 47.8, but they're close. Apple is kind of hard to beat in single core scores right now. They've got that market cornered, and we'll see that pattern again. Now, Speedometer is a JavaScript runtime. Web tooling benchmark is another one that I use by V8. Yeah, those are the same V8 people that actually write the engine. This tested JavaScript toolchain like TypeScript, Babel, Cursor, and stuff like that. Here, the Ser 9 came in at 20 on the TypeScript score and 18.8 on the geometric mean. Both Mac Minis are way ahead, 35.99 each on TypeScript. By the way, the M4 base and the M4 Pro tie on that one. The geo mean is where they separate a little bit. And after running the Ser 10 test, it landed on 34.14, that's for TypeScript, and 28.62 for the geo mean. Okay, hold on. Now that's 65% jump on TypeScript over the Ser 9. 65. And the geo mean is up over 50% here too. This is by far the biggest generation over generation win I've seen so far for this machine. And look at that TypeScript score. It's within 5% of both the Macs. By the way, I'm looking over here because that's where my computer with the chart is. So the Ser 9 trailed the Macs by 75% on this test last year. This year, the gap is essentially gone. The geometric mean is still behind by 11 to 13%. Not a clean tie there, but this mini PC has finally caught up to Apple's Mac Mini on a real V8 toolchain benchmark. All right, the obligatory Geekbench benchmark. I don't usually like to dwell on this, but in this case, it's important. Everybody uses Geekbench to measure this stuff, so might as well throw it in. And last generation Ser 9 came in at 2889 for a single core and 14890 for multi. The M2 Pro Mac Mini, that's the one from, it's the bigger one, okay, from a couple years ago. That one was 2700 and 13,000. Now the M4 Pro, that's the number to beat. It's got pretty decent score, 3945 for single and 15,321 for multi. You can see the Ser 8 was quite a bit behind on that one. And the Ser 10, that lands at 2993 single and 15,216 multi. Pretty big leap over last generation. And for the single core, it's not a huge difference. However, the multi-core, compared to the M4 Pro Mac Mini, that's a difference of less than 1%. It basically ties Apple's flagship Mac Mini on multi-thread Geekbench. Maybe this will translate to when I do compilation tests in a bit. All right, it's time for the meat. Can't believe I just said that. That's just... Some vegetarians might object, but I don't care. I eat meat. I like it. It's good. Lamb is my favorite. Beef, but a good steak is really good. All right, enough. Python Mandelbrot. This is a test that I run to show how pushing all the cores to the max with an interpreted language like this, interpreted test like this. This is a Python algorithm, and it's the channel's signature move. It pegs every single core to 100%. Oh yeah, there it goes. You can see that working quite nicely there. Now the Ser 9 already beat the M4 base on this. 28.64 seconds versus 31.41. Shorter number is better in this case. B-Link ahead of Apple Silicon here, folks. And that's the previous generation. As an aside, I also ran this on the X Elite mini PC that came out. Some of you might remember that. Well, the Ser 9 tied with that machine, which is the first generation X Elite that was the most powerful one. I want to see the X2 Elite in mini PCs. That's gonna be a killer one. Anyway, M4 Pro was still the one to beat. 23.24 seconds on that one for this test. Considerably faster. And the Ser 8 was quite a bit slower, 42.73 seconds on that one. So we saw a 33% jump from SIR 8 to SIR 9. That's huge. How does the SIR 10 do? Okay, SIR 9 was 28.64, SIR 10 is 28.9. A nice number here. This is the fastest that it got. That's literally a quarter of a second difference, so basically kind of the same. Still beats the M4 base, so that part of the story holds, but generation to generation, nothing here. So this was an interpreted multi-core test. But before we get into compiled multi-core test, I want to back up here and show you this project, which is something I ran before on those machines as well. This is a large monorepo by Victor Safkin. This is NX monorepo, and it includes 26,000 NX JavaScript components. There's a lot of components, but they are very small. So it corresponds to a medium-sized enterprise repository, basically JavaScript at scale. There's 5 Next.js apps here, 20 libraries, 250 components each, and NX provides a cache, but I ran this build without a cache just to see what it's like. Before I get your hopes up, this test didn't work out so well because there's repository drifts, and I just don't believe the results because it can't be like this. Last year, SIR 9, we got 14.1 seconds. The M4 Pro was 7.76. The M4 Base was 7.36. Yeah, I know, M4 Base won again. Third test in a row. So what I like about this test is it's a TypeScript toolchain. It runs through Node, lots of process spawning, lots of file system hits. Apple Silicon's been good at this for years. So this is where I thought the SIR 10 has to climb, right? Maybe not dominate, but climb. And SIR 10 landed at 2.91 seconds. And I thought, come on, 5 times faster than the SIR 9? I don't think so. So because of the way this test is set up, the NX tool itself probably got faster and optimized. And unfortunately, I'm gonna have to say goodbye to this tool because, yeah, when you're doing benchmarks, you can compare things side to side, side by side, over time. But when you're doing real world projects, then things tend to drift a little bit. So it's not the same workload anymore. We can't really compare it to the previous builds. However, it builds this thing in under 3 seconds, which is pretty incredible. And that's good for both the chip, the machine, and the monorepo and the tool. So good for them. We're gonna skip this test next time though. I wanna move on to a benchmark that I designed. This is a .NET build, and this build basically generates 100,000 namespaces and classes, each one with recursive calculations and nested loops, so the compiler can't just throw them away and skip the work. It has to do it. Same workload every time, year after year. This is the test where the SIR 9 beat the M4 base model. 91 seconds. That beat the M4, which got 106.7 seconds. The SIR 8 was 109 seconds. And the only machine that was meaningfully faster was the M4 Pro at 66.4 seconds. So this is the test for Gorgon Point. If Zen 5's IPC story is real and the math behind the new generation actually shows up in compiled code, it's gonna land the hardest here. And this is also the loudest test. I'm hearing the fans here. Here it is being built. Pretty much all the CPU cores are involved in this one, although they don't go as hard as that Mandelbrot test, but still, it's more realistic. And we got 90.9. That's a difference of 1/10 of a second. This was supposed to show the new chip's strengths. Basically, we got the same result as last time. But the SIR 10 still beats the base M4, so B-Link continues to be a better choice than the base Mac Mini for a compiler-heavy .NET work. But on the M4 Pro, Apple Silicon leads still. Now again, the previous test was synthetic, so I wanted to go and to build a real thing. Umbraco, that's an open source CMS. It's been around for ages. It's a mature .NET project, open source. But again, this is a real project on GitHub. So again, there's gonna be variation over time. It's constantly evolving. They're adding features, they're refactoring, pulling in new dependencies. So the number I might get might not be fully repeatable year after year. But if you have a machine and you wanna build it right now, compared to my result that I'm gonna get, then at least it's going to be valuable in that way. If you want to compile this yourself, you can find it on GitHub right over here. They're constantly updating it. 11 hours ago was the last update. Can't believe this thing has been around so long. SIR 9, 149 seconds for the compilation. SIR 8, 161. So gen over gen on Umbraco was only 7%. Why is that? Well, because real builds are IO heavy. There's disk, there's NuGet, the file system. And again, Mac dominates this one. M4 Pro, 84 seconds. M4 base model even destroys the B-Link, 93.9 seconds there. All right, got it done. Seer 10 lands at 161 seconds. Now hold on, that's slightly slower than the Seer 9. What's up? And it just happened to match the Seer 8 from a couple years ago, both 161 seconds. So again, on this one, a real .NET production app, full release pack, every project. The Seer 9 happened to be the best of the three here at 149. By the way, I want to flag something real quick here. The first time I ran this, I got 217 seconds on the Seer 10, and that was with Windows Defender running. So I had to turn that off. So if you're doing this kind of compilation, you got Windows Defender running, you might want to exclude your code directory from that. And the way I have my systems set up, first of all, I automated the build, the deployment of this package, and I do have videos on how to set up a development environment on a Windows machine and on Macs. So check that out, it's on my channel. And I recently created a script to automate that whole process too. I'd recommend going through the whole thing just to know what's getting installed, and then you can use the script on your subsequent builds if you want. It's up on my GitHub, I'll link to it down below, but I made a special video for members of the channel. Thank you to the members, by the way, for supporting the channel. I made a video on how to run it. It's all in the instructions on the GitHub though. If you want to just go check it out, I'll link to it. All right, let's switch topics to another popular thing that's happening these days in 2026. Oh, I don't know, what could that be? AI.
Nice.
This thing has a GPU, a CPU, and an NPU. So this little box has 3 chips on it, and they all can do AI. There's a 12-core CPU, Radeon 890M iGPU, and there's a 55 TOPS XDNA 2 NPU. AMD says all 3 together do 86 TOPS of AI work. TOPS. Yeah. We all know the marketing stuff. Now, out of the box on Windows, the most popular tool people use to run local LLMs uses one of those, but it's the wrong one. So let's do it. I'm gonna do llama run qwen 2.57b. I'll do verbose, and I'll do my architecture prompt, which produces a pretty long output. There it is. Results are streaming, looks pretty good, but let's check Task Manager. The CPU looks pegged, but the GPU is not being used at all. NPU, 0. Doesn't even show up here. 3 accelerators in this box, and one of them, the regular CPU, is doing all the AI work, and we don't want that. That's gonna be slow. Well, there is a Vulkan flag that you can set on the environment for llama that'll allow you to use the GPU. So on day 1, the AMD AI chip you just bought is gonna be doing AI on the part that isn't the AI part. Doing AI on the part that isn't the AI part. We got a result at 14.2 tokens per second. So to enable that on Windows, you just go to the environmental variables and set the llama Vulkan flag to true. If there isn't one, just add it. And then just make sure you restart llama. All right, here we go. That looks like it's going a little faster, doesn't it? Let's take a look at the GPU, and yes, there's the GPU compute. It's happening on the GPU now, which is beautiful, 100% utilization there. So I ran a couple of them as a test. Llama 3.23b, we went from 27 tokens per second to 37.5. Qwen 2.5 1.5b went from 47.5 to 68.3 tokens per second. So there's some differences there. So we've got the iGPU thing going, but there's still one chip in this box we haven't even touched, and that's this NPU. And guess what? The old one had it too. AMD's been putting this thing on the box for 2 years and nobody actually benchmarks it. So first try, I used Lemonade Server. They got these hybrid recipes where the NPU does the prefill and the iGPU does the decode. Those are the 2 stages of inference. It even comes with this little handy app. Let's do a high here. It's kind of hard to see down here, but tokens per second is 14.3 on this one. This is a 1 billion parameter model. We can see that it bumps the NPU just a tad bit, and then it uses the GPU for the decode. What if I use my longer prompt here? Boom. Okay, we see a little bit more NPU activity. That's the prefill, and the prefill happens pretty quickly. Most of the work happens on the GPU though, because that's the decode phase. So the NPU is kind of built for that stage, for the prefill. It's a different job, different chip. So I ran a longer prompt, and it was a 4400 token prompt with a short reply. And that's the actual prefill workload. On Qwen 7b, the CPU got 255 tokens per second there. The Vulkan iGPU, 240. And the NPU, with the hybrid mode, 631 tokens per second. That's 2.5 times the iGPU, all on the same chip. So if you're streaming chat use the iGPU. If you're doing RAG, agents, or coding assistants, anything that dumps a long context, then you want to use the NPU. And since this is a Lemonade server, you can actually connect it to a coding agent. It's for another video. Perhaps you want to see that. Let me know in the comments down below if you do. I'm curious myself because I haven't actually tested Lemonade before on the channel. But now I want to show you something that this hardware does that if you just read the specs, you'd say, no way, that's not possible. Qwen 2.5 14B, that's the Q4 quant, over 8 gigabytes on disk. Now the iGPU on this chip, it shows you 4 gigs of memory, just 4. And I'm gonna load 8.37 gigs of weights onto a 4 gig iGPU. This shouldn't work. And it's loaded. All 49 layers on the GPU. How? All right, so I'm watching this in real time. Get counter on the right side, GPU adapter memory. Before I loaded the model, it was 0.69 gigabytes dedicated, 5.26 shared. And after 3.62 dedicated, 17.36 shared. 20.98 gigabytes of iGPU memory in use right now. On a chip, the device manager says there's only 4. So that's UMA, Unified Memory Architecture, which the M4 and the Apple Silicon also has, but this has it too. So when the iGPU asks for more memory than its allocation, Windows just quietly grabs some from system RAM and says, here you go, hands it over, and the model has no idea. So prompt processing was about 50 tokens per second, generation 8.8 tokens per second, a 14 billion parameter model. And by the way, on this machine, there's still like 25 more gigabytes of unified memory headroom left here. So a 22 billion parameter model would fit, probably even a 30 billion parameter model would fit too, with Q4 on the iGPU. Now remember that the Seer 10 and the Seer 9 have the exact same GPU in there. So if you bought a Seer 9 last year for the AI stuff, your hardware is still fine. Update your software. So quick recommendations here. You should buy the Seer 10 if you care about the NPU for RAG and long context AI work. If you want upgradable RAM, because Seer 9 doesn't have that, or if you want that 10 gig Ethernet port. You should probably skip it if you already have the Seer 9 and your main workload is the iGPU LLM path. Save your money until the next generation, which is Medusa, comes out in 2027. Another scary creature that I wouldn't want to mess with. Now besides these, there's actually a bunch of other mini PCs that you can consider, and I made a video up here and up here. You can check those out. You might be interested in those. Thanks for watching, and I'll see you next time.